Hello class, my name is Carlos Barrera and I'm going to be talking about the decorator design pattern. The decorator design pattern works by simple of additional responsibilities to an object without adding responsibilities to an entire class. In other words, the decorator design pattern is able to add responsibilities to individual objects dynamically and without affecting other objects. If you've taken the BYUI Java oriented, object oriented class, you've had to deal with the decorator design pattern, but we called it a wrapper or wrappers. So you know this. A good demonstration of the decorator design pattern would be when we're developing classics for the spending trend in graphical. Hello class, my name is Carlos Barrera and I'm going to be teaching Hello class, my name is Carlos Barrera and I'm going to be talking about the decorator design pattern. The decorator design pattern works by simplifying the attachment of additional responsibilities to an object without adding responsibilities to an entire class. In other words, the decorator design pattern is able to add responsibilities to individual objects dynamically and without affecting other objects. But you already know this. If you've taken the Java object-oriented class that BYUI has, we've dealt with this. But they were called wrappers. So, got this. A good demonstration example of the implementation of the decorator design pattern would be once we're ready to add graphical designs or GUIs to our product. It'll be implemented during the spending trend and graphical format. Spending trends and graphical format. The reason why the decorator design is appropriate for displaying spending trends graphically is because we'll just be changing the object's skin versus its guts. Implementing a class that covers all of the possible graphical displays would be wasteful because most graphical displays won't be even used. At least they won't be used by everyone or consecutively. If you're using a pie chart, you're probably not going to be using a bar graph, at least not at the same time. So instead, we can create the display class and then add responsibilities as we see them fit or as the user asks for them. The upsides of using the decorator design pattern is it gives you more flexibility than static inheritance. With the decorator design pattern, responsibilities can be added and removed from an object at runtime by simply attaching and detaching decorators or wrappers. In contrast, with inheritance, it requires the creation of new classes for each additional responsibility. The removal of inheritance also requires substantial modifications to classes instead of modifying a single object. The second upside is that it avoids feature-laden classes higher up in the hierarchy. Inheritance can attach unnecessary responsibility to a subclass, while decorators only add responsibilities as they are needed. This allows the construction of simpler classes and optimization of overhang. It also simplifies the addition of responsibilities because the probability of conflicts is minimized due to the simplicity of the parent class or the class that you're inheriting from. Another upside is that some languages like Java don't let you have multiple inheritances. They just let you have interfaces. This might be an issue because you might want to get an inheritance from like a grandparents, but you're just not allowed. So instead, you can create micro classes and add those as you see fit. So basically, the decorator design pattern allows you to modify objects without having to modify classes or have grand classes that basically cover all the possibilities that you might need. Okay, now my partner is going to explain the rest of the decorator design pattern. Thank you.